Okay, so welcome to the first of the Proper HyperWorks training webinars. So today we're going to cover HyperMesh and, well, cover as much of it as absolutely possible. So we'll be moving pretty fast, which I do apologize about. So just a bit of background on HyperMesh. So this is the #1 preprocessor globally. And a big reason for that is because of the large versatility of file types that can be imported and exported, as well as the fast manipulation and cleanup of geometry and meshing between 2D, 3D, and 1D. So we're going to try and cover most of that today, or as much as possible. I'm going to show you where you can at least find the tools to be able to do a number of the cleanup and meshing that you'll need to do. So we'll jump straight into it. And okay, so what I have here is just a simple geometry. And I'll just make sure this is all seeable for you first. Okay, so what I'll quickly cover is just some basic importing. When you first open up HyperMesh, one of the best things or first things that you should always do is, if you haven't done on first opening, is always check by clicking this little person here. Always check your user profile. As a default, it will come up in the HyperMesh section here as a default for HyperMesh. So this is where you choose the kind of setup and analysis that you're going to be doing. As a good starting point, I would always recommend having either this OptiStruct in HyperMesh, or going to Engineering Solutions and choosing the aerospace and having that as OptiStruct. One way to help keep this coming up as you open it up is always tick this box here, always show its startup. That way then you can always be sure that you've started with the correct profile that you want to work in, because as you're building your mesh and during your cleanup and all that, if you switch between the user profiles, you can sometimes get problems. So it's best to start in the profile that you want to work in from the very beginning, unless you export correctly and then re-import correctly again as well. So for this one, I'm going to be in the aerospace OptiStruct profile. Okay, so upon having geometry loaded up, is you'll go to File, and you can either start a new session or model with a completely blank screen and build it with surfaces from there. But generally you're going to import. So here we've got a number of different import options where you've got your model, a solver deck, geometry, you can import connectors, and also a bill of materials or a BOM. So by clicking on any one of those, you are then able to select between these in this little section here. So the model will be as a standard HyperMesh model, which, unless if you're working from CAD, you generally won't have this. So with your CAD, you'll want to be looking at import geometry, and then you can choose your file type. And through here, we've got all these different types of files. You've got step files, SolidWorks, Parasolids, you got your JTs, Inspire, which is what we covered last week, IGES files, CATIA, Axis, or you can do an auto detect. And it's just the same way then. Once you choose that, you click on your file and select that. So if I wanted to open up a step file, I'd simply select that, and in my files there, it comes up with step. And then you double click that, and when it pops up in here, then you'd click import. So that's a very simple way of getting this up. Just to cover a couple of other file types, with your solver decks, these will be like a mesh file, like a FEM file or a Nastran file or a Radios mesh file. So what these are, these won't contain your surfaces, but all FE that is contained within the model to run an analysis. So for your OptiStruct, this would be a FEM file. For instance, then for your Nastran, you would use this for CFD, and for virtual wind tunnel. As you can see, we've got LS Dyna, which is another program. You've got Pam Crash. Here's a standard, just a basic CFD one. There's ANSYS up here as well. H3D, which is an output file from HyperMesh when you run an analysis. STL file, so a standard STL mesh file if you've done a scan. Again, so all your SolidX are more related around your meshing files. We won't, unless you're really good with SolidWorks or CATIA and creating bill of materials in there, probably won't cover this too much. And connectors, this is if you've built connectors in your CAD models, but again, probably won't worry too much about that. So generally, probably just look straight at import geometry. So once you've imported, let's jump out of that, is you're going to come up with a basic screen like this. You'll have some components. You'll have your assembly hierarchy, like your tree that we saw in Inspire and Virtual Wind Tunnel. Yep. Oh, and also, because I can't see if you send any messages, just please make sure you turn your microphone on, and feel free to chime in straight away with any questions you might have. So here what we can see is a basic geometry, can be whatever, a bracket, a simple bracket, just for demonstration purposes this is, with another surface on top. Now this has been modelled as this would be used to put a bolt through the holes. So I'll also show you a really good way of creating, like fast way of creating 1D elements to simulate bolts and beams, which is also a great way of building the first model of your cars. So what we're going to do first is going to do on this model here, there is some geometry cleanup that we need to do. So one really good thing is to click this little computer icon here, which is your visualization options. And as we can see, we've got a number of different things that we can have a look at. So we want to look at the edges first, which means at the moment this is solid. So we want to click this tool here, which takes it to a wireframe. So now all we've got is just the outline of all our surfaces, or solids, depending on what you've got. And what we're going to do is we're going to unselect all these. Now, I know it's a little bit hard to see, so I do apologize. Is that a bit? Hopefully that's a bit easier to see now. So back to the visualization, is all these lines here that are being shown are free edges, so edges that aren't connected to anything. So these are where we need to do some cleanup. If we zoom in, we can see that we've got bits and pieces hanging off where they're not meant to be, or this could mean a number of things as well. We've got missing surfaces or anything like that. So when you import CAD, it is always a very, very handy thing to do this first and just have a look for free edges, missing surfaces, and odd bits in the geometry, because it is very common for that to happen when you do bring in CAD to a program like this. So what we're going to do is we're going to turn all these back on, just suppressed and shared. And we're going to go back to our solid geometry. We're going to try and find out a bit more about why these were free edges. So if we take a look back into it. Okay, so our first one is up in here. So what we're going to do is we're going to zoom in there, and we can see that we've got two lines that have connected to the two same points. So if we turn everything back on, we can also get a bit more of an idea what's going on there. So why this has happened, this could be any number of reasons. It's just split the surface for some reason, or the CAD had a bit of funniness to it. So what we're going to do is when we go to the Edge Edit tool, so make sure that you're in geometry first. So we'll go to the Edge Edit tool. And now you've got a number of different things you can do. You can toggle edges. So this is basically putting them back together. Unsuppress or suppress, replace, equivalence, unsplit edge fillets, and by feature. So what we're going to do is we're going to use toggle here, and we're going to make the tolerance a little bit larger, say 0.1. And all you need to do then is just select the line. So double click on the line that you want to toggle. Now, so whenever you want to go back again, like in the last thing, it's just Control Z. See, so if I toggle the bent line out of shape here, see how that the second line jumps to that? Now that's not the line that we want, because now we've got a little bit of funniness, but it should be okay. So if you're not sure about if you selected the correct line, always Control Z, go back and just do it again like that. So now we can see that that's not a free edge, it's all green, which means it's all joined up. So now what we can do is we can have a look at some of the other sections here. So again, the exact same thing with like the other bit has happened here. So we'll just toggle this edge, bring it back together, and make it green. Okay. So now what we'll do here is I'm going to do a different way of cleaning this bit up. So if we go to F4, so function and F4 will bring you up with 2 nodes, 3 nodes, 2 points, 3 points. Oh, this is the distance check as well. So if you're not too sure about tolerancing, this is also a good point. So I can always check my distance there, and it's telling me it's at 0.2 of a mil. So it's very small, but that means that if my tolerance is at 0.01 or 0.1, it may be just outside of being able to stitch these gaps, which means you can also get errors and warnings. So it's always handy to check distances before doing your tolerancing. So what we'll do is go to function 3. But so as we don't have any nodes at the moment, what you can do is when you've meshed, function F3 is a great tool for fixing nodes like this. So if you have nodes separated, you can easily delete elements and connect them back up. Go back to the edge edit. So I won't go around and clean every little bit of this up. There are some. So what we're going to do is we're just going to check some surfaces, because I'm fairly sure there should be a missing surface here. I've just got to find it again. Either way, so what you can do from the surfaces tool is lines. Is with the auto create, you can actually create surfaces from all 3 edges. But for instance, I couldn't do this here, even if there was no surface there. I wouldn't be able to use this here because we don't have a free surface there. So that at the moment is connected edge. So the only way to use this, the spline and filler, is you want to have all 3 edges, and you can auto create. So if you've got all 3 edges, like what I can do is go to function F2. I can delete the surface. I can show you how that works. So now for instance, if we've lost the surface, and now we can see that these are all red, we're able to use now. So I'd untick that. Want to keep tangency and auto create, just click on the red line. Now it's created our surface. Although this would be although I would reject this surface. As you can see, it's not very well built along this line here. So you can always hit the reject tool and it just takes it away. So another way of creating your surfaces is using this tool here, the ruled. Now, so you'll see there's 2 sections for line lists, which means you have to select a minimum of 2 lines for this to happen. So what we'll do is I'm going to select that little one, this corner, this long one, and then this corner again. And then I'm going to go to the second section of the line list. I'm going to select that red one and then the big back one. And when we go create, see how that has now created that surface on there? But as before, it wasn't completely joined. So you would use your tools again to find out why this is not being connected correctly. But yeah, so that is a quick overview of how you can look at doing a quick look at creating your surfaces, toggling your edges to clean up your geometry, as well as creating surfaces. Now, you don't have to just create surfaces from free edges. You are able to create surfaces from your vectors or your X and Y and Z axis, points, whatever you need. If you do need to just say, for instance, create just a general box or a solid box, it's a very quick way of doing it. You can simply go, look, I want to create it on my Y axis, and you can create just a point. So let's say we want to create it at that point, and we put in a size. So for instance, we'll go 5, go create, and now I've got a square there. And then if you want to turn that square into a solid, just hit return, go to Geometry, Create Solids, and you can go Drag Along Vector, Bounding Surfaces, and this is the same not just with solids but surfaces as well. So you can see here you've got all these different kinds of surfaces that you're able to create. So what we'll do is we'll just create a quick solid. So I'm going to say drag along a vector. So I'm going to select my surface and I want to drag that upwards. So I'm going to click this button here and go to Y-axis, and I'm going to tell it to go up a distance of 5. So we hit the drag plus. Now all of a sudden, see how the topology in that has changed to solid green? That means it's a solid. So one way of seeing what kind of topology as well when you import something is not just from these visualizations tools to see what is free, but also from this tool here, the geometry color mode. So you can go here by assembly, by part, by component, and I want to go by 3D topology. So you can see now that the one solid option, which is 3D, has stayed that see-through fluoro green, and all the rest has gone to this weird blue. So that means then that solid green is 100% solid, and we can even have a look at the 2D topology as well. Now that's gone to solid blue, so we know that's not 2D, and all the rest of it has gone back to the original color, which means it's 2D. So we'll just keep that on auto for the moment, and then also with FE, you can do the exact same thing as well. So with the FE button, you can all have a look at all the elements by component, property, material, assembly, 1D, 2D, or 3D elements, thickness, element quality, whatever you choose. So it makes it really handy and really fast to be able to quickly visualize everything that you need. And yeah, so I'm just going to delete that solid because I don't want it in there for this, and it's a very quick way to do it. Delete solid. And so actually when I did do that as well, did you notice how, sorry, you can go solid, displayed all by collector. All I did then though was click on that and middle click. You can also do it by delete bounding surfaces. So if I hit Control Z, the solids come back, because if I just wanted to delete a solid but leave the surfaces there, untick this. But if I want to delete the solid and the surfaces, have that selected. And you can also do the same thing with delete associated elements, where there's no elements in this, so I'll keep that off. Delete entity, and the whole thing goes. So that's a very handy way as well to do that. Okay, so what we might do is I'll quickly first off show you how to create a mid-surface very fast. As you are doing automotive work, the majority of the work you'll do will be in mid-surfaces. So very, very fast way of doing this is just going to Geometry, Create, Mid-Surfaces, and you can go to Auto. Now, because I haven't cleaned up the entire thing, hopefully this should still work fine. But what you can do as well, you've got surfaces, and you can choose by surfaces or solids. Whether if you wanted that to be a solid, you can do the same thing. Is that a closed solid, incomplete solid? Again, it's all dependent on how you've set up your CAD and how the CAD is. You can auto mid-surface, or you can really go through the whole thing, but this is just a fast auto mid-surface. So what I'm actually going to do is I'm going to select all my surfaces. So you can go Shift and it creates a box. See how I left this one out, because this isn't a solid, it already is just a surface. And so now I've got all my surfaces selected by holding Shift, and then using the left mouse button you can draw a box to obviously put in, select everything that you want to select. So then you hit Extract. Just give it a minute. So why you're using mid-surface as well is to be able to mesh in 2D elements, and you give those 2D elements a thickness. So that's what's called a shell mesh. So we can see here it's gone a bit funny because I didn't do a full cleanup of it, but that's okay. It's enough to work with for the moment. And one really good thing as well is when you do this auto mid-surface, is it gives you a brand new component with the mid-surface in it. So what you're able to do is we can now turn this just the full thickness geometry off, and that's what we're left with. So as you can see now, that is just a thin surface, And then when we turn that the full thing back on, you can see how it's directly in the middle of the thickness. So what you would do now is this is used for just being able to create a full mid-surface of a thin metallic part. So like this bracket, this is how you would do it, or if you've got like your rear lifting bracket, that's a perfect section to be doing this on. Any aluminium chassis, really perfect to do it on again. So yeah, definitely play around with it and see what you can pull out of it, and what you think you can use it with is always a handy thing. So what we're going to do now as well is I'm going to show you how to organize components, because see how this single surface here is in the main part? I don't want that. I want to be able to turn off this larger section but keep that surface. So one way to do that is in the components area, you right click, create component, and now we'll just give this a name. So we'll just call it bolt hole, bolt underscore hole. Now, how we can organize this. Now, this is also how you organize all elements, solids, shells, anything, surfaces, is geometry and organize. So anything you want to organize, you've got nodes, free points, lines, surfaces, solids. If you do it for mesh, it's the same spot, mesh, organize, nodes, elements, component, include, depending on what you want to move. So what we're going to do is we're going to move a surface. See, it already comes up there. You can select down and choose different things, but that's already highlighted. We'll just select that and move. And now we see that the color's changed green to the component color. So now we can turn off this mid-surface. And also what this mid-surface does as well is it also helps us to find other problems. So if something like this does come up when you're mid-surfacing, you automatically know that there is a large problem with the geometry that you've brought in, and that you need to look a bit deeper into the cleanup. So normally I would, just being a bit conscious of time today. So what we're going to do is we're going to start off with doing some 2D meshing, and then we'll move into creating a 1D bolt mesh, and I can show you the fast tools of how to do that. So I'll just quickly ask, is there any questions up until this point at the moment? Please feel free to shout out or chuck it into the chat. Okay, so no questions, so I'll keep moving then. Okay, so the 2D meshing in this is really fast, and it's very user friendly. So one great thing you've got about, sorry, I'm just going to have a drink now. So a couple of things that you can use 2D meshing for is for shells and mid-surfaces, but you can also use it to create what's called a skin mesh, and this helps to create a better built 3D mesh without having to do the entire volume meshing, and then you've got, say, a million elements in there that you need to check one by one, or check. By creating your 2D mesh first, it provides a very fast, it provides a lot less elements to have to go over and check, and then when you create your 3D mesh, which I'll show later on, you can actually connect it to your surface mesh. So you know that your surface mesh is well created, which means then your volume mesh is something really good to build off. As well as for mid-surfaces, and then when, which I won't show today, that'll be next week, when you're creating your properties, you give it a shell element card, and then you can give it a thickness, so that way then you can pull out the stresses and perform your analysis on your mid-surface surfaces. So what we're going to do first is, there's a couple of ways to enter the 2D meshing panel. Down here we can see the 2D, or to enter the auto mesh panel, you just go function F12. Function F12. Okay, so you can see here we've got a number of different things to obviously mesh with, and a number of different options to go through. You've got size and bias, got batch mesh, edge deviation, surface deviation, rigid body meshes. You can choose whether you want the elements to the surface component, current component. So a current component is one that is highlighted such as this. Now you can always right click on the component, make current, and it changes But for this one, we're going to keep it as the bolt hole, make current. And you guys will normally be using first order elements, but you can switch between second order. Now, is anyone aware of the difference between a first order and second order element? So I'm actually putting this question out. Does anyone actually know what the difference is? And if you think you know, don't hesitate to shout out, because it's always good to have a crack. No? Okay, so the difference between your first order and second order elements is the amount of integration points. So if you were to, say, draw a triangle on a piece of paper right now, at each of those points is an integration point where you've got all the calculation performed. So now that would be a first order, same as a square. If you draw a square at the 4 points there, they're your integration points, and that's where your calcs are going to be coming from. If you go to second order, that means then, say, now your square where it had 4 integration points now got 8. So there's going to be another point in the middle of each of those lines, and same as a triangle. So if you do use second order elements, you need to be aware that, yes, your analysis will probably be closer, but it will take a lot more time because you've got a lot more calculations that are being performed, which is something that needs to be taken in consideration with every model that you mesh and set up. The more elements and more integration points or more degrees of freedom, it's always more calculation to be performed. So you need to be aware of this, because this is something that can really get you caught out, especially when you're first learning out. And if you accidentally put in a wrong mesh size, that could be the difference between 20 minutes of work of it trying to figure out 2 million elements to build, other than, say, 5 minutes and you only get say 2,000 elements built. Like, you need to, so it's always worth double checking before building your elements as to what they are. So I normally always work in first order unless I'm doing something that requires second order. Really the only time that you'd use second order is if you've got extremely fine features that you can't get 3 elements through the thickness. So you use second order elements there because you need the integration points. For this one, we'll use first order. So what I'm going to do now is, we can see here when we zoom in. So zooming in, you hit Control and the middle mouse roller, as well as moving around and panning is Control the left to move it, and then the right to move it, and the left is to rotate. We can see that little square there. So we've got this little legend down here telling you the distance. So this is units. So it's always a good thing to remember that HyperMesh does not have an actual unit system. So you need to be aware what units the model is when you import. This just tells you 1 unit length. So this could be 4 meters, could be 4 millimeters. For this model, it's millimeters. But you need to be aware as well as to what units you've built it in. So what we're going to do is, I'm just going to mesh this with an element size of 1 unit. And I've got it mixed here between quads and tris. I'm going to click that button. I'm going to choose specifically quads, hit surfaces. Another one that I always use is link opposite edges with aspect ratio. So that makes it easier. Once we mesh this, you'll see why it makes it easy. And you just hit mesh. As we can see, we've got a pretty good mesh there. Now this is where it's easy to see. So on this circle, see how it's split into 2, and we've got 10 and 10 on each side. If you then just click one side, the other side should change, but hang on. Okay, it's not. But normally if you click one side, so linking the opposite edges will then allow you to change the density, and it will change the exact opposite edge to that same density. So what you do then, so if you want to change the density of this, you can go to 12 and 12, not change anything else, just hit recalc all. Oh no, sorry. Go 12, 12, mesh. Now we haven't changed the outside number of elements, but the inner circle elements have all changed. So this is a really good thing to be able to do for features like circles, bolt holes, anything like that, to be able to get you through thickness elements as well. So if you've got a bracket that you want to analyze the stresses on, and you can only get you've only got 2 elements at a size of 1, by changing that then to 3 elements through, will give you a much better analysis as well. So what we're going to do is we're going to leave it at that for this, and I'm going to mesh now is this bottom surface. So because when I did mesh, then we had it to current component because we're going to the bolt hole now. I'm not going to change that, but I am going to select 2 elements to surface component, and then I'm going to select the surfaces. So there we go. So I've selected all those surfaces. Now, without changing that, these elements will automatically mesh into the middle surface component, because that's where those surfaces are located. And then what we can do is, we know that we've got 12 elements around this circle, so we can change each of those to 12, mesh it. And that's a quick way of doing your 2D mesh. I'm just going to quickly show through some of the cleanup tools. So on your sidebar here, you can go to 2D. Now you've got a number of different things here to go through. You've got edit element. You can create, combine, and split. And you've got quads, tris, plot Ls, and then your 3D elements. So this is your 1D, 2D, 2D, then all this other side here with your hex, penta, pyramid, and tetra are all 3D. So you're able to, if you delete an element, for instance, I'll just quickly show. So function F2, and I select this to elements, select that, then delete, return. So there's no element in that section. We can go back to the node list because we have nodes there already from the other surrounding elements. I want to create a quad. Bang. Now that's created it in the current component. So what we want to do is now move that over to our mid-surface component. So we go mesh, organize elements to component, select the element you want, choose the component, and move. So it's that simple to do that. A number of other cleanup tools is you've got your quality index. Now, this is all your meshing rules. So I don't have the time to obviously go through everything here, but this is what optimizes and helps to clean up your elements to really, really good mesh. So what we can see here is we've got on the top surface, as you can see, there's no yellow elements or red elements, which means this is well and truly within our specified tolerances, which is really good. We've got a few yellow elements here, so this makes it easy to work with. So what we can do is, on a fast basis, you can just click on your cleanup tools, and you're able to select between place node, element optimize. Look, they're the main 2 that I work with. Unless you're working, unless you've got mixed elements and you've got some really skewed elements, you can go split quad element, which will split it into 2 tri elements. But for this one, we can actually, for place node, I can actually move the node around myself. So you can see here now that this element is turned red, which means it's a failed element, and generally the analysis won't even run. So you need to spend quite a bit of time in your cleanup to make sure that you have gotten the mesh to the best quality that you can. So what we can do is move that around, just that single node. Now they've all gone, so which means they're all within the tolerances that are specified. I can go to element optimize, just select the element, and as you can see, fixes itself. Or you can do node optimize, again moves the node to the best spot. If you've got tri elements in there, which we don't have, you can drag tri elements from the edges to or from significant areas to centers of areas for analysis. So if you have say tri elements all along this surface here, you'd want to try and drag them right into the center of your main section, because quads will give you a better FE analysis. So this is where you can find all those tools, or you can click start and it'll just automatically take you through the bad elements. Now, I wouldn't recommend doing that when you're doing a first cleanup, because you could have 1,000 elements and it could take some serious time. Another one is you've got your element cleanup tools. So these here is your criteria. that you would have specified. And you can go into those and edit your criteria parameters as well. So this is for cleaning up elements if you realize, hang on, my maximum interior angle for the quad is too high or too low. You can specify that in here and clean up your elements according to the criteria and parameters that you set up. You've also got your mesh edit, so we won't worry about too much about imprinting and extending the element layers at this time. You can also then go to tools. You've got your edges. So this is where, after your mesh, you find edges in your mesh. You can find free edges, bits where there is poor connectivity. Generally, if you go into check elements, so this is also where you've got all your criteria as well. So if you go to check elements, in your 2D section, you can set up your warpage, aspect ratio, lengths, minimums, maximums, Jacobians, min angles, maximum angles. So when you're doing this as well, it's I definitely recommend going through some books out there that will give you some good ideas, other analysis that have been performed on setting up your element criterias. Because if you have these set up wrong, then becomes that your analysis could be hard to validify those results. So it's always worthwhile having a bit of an understanding about why you're setting up and how to do that. Again, with the 3D elements, you can do all the same thing in there. Now, if you have, when meshing as well, if you the O button, just by clicking on the screen, just hit O, comes up with your with some settings. So these are all your cleanup tolerances for your geometry. These are the minimums. So with the mesh one, as you can see, you've got element size, node tolerances, element order. Sometimes you might find that you can't go below a certain element size when you need to. If you hit O and then go into the mesh, and you can see what your element size is. So if I was, say, trying to go to 0.05 element size, it may not have let me because my specified element is 1 here, and my node tolerance might not be correct for that. So it's always worthwhile having a look at what your tolerances are prior to meshing, as that will also help increase the speed into which you can create your mesh. Okay, so I'll keep quickly moving. Sorry guys, it's just a lot to cover. I do know that, I'm sorry. So that's a quick basis on 2D meshing. Now I'll just ask again, does anyone have any questions on this, or anything they need clarified, anything they're not sure about, or else I'll keep moving on. Okay, so what we'll do now is I'm just going to take you through quickly these bits up here, particularly the utility panel. Whenever you open up, if you don't have a panel that you need, always check out the view option, browsers, HyperWorks, HyperMesh, and this can give you a browser if you don't have it, or if you're using just a straight HyperMesh, I think it's in edit or file. I know, unfortunately, they change around a bit, but in HyperWorks, it's always in view, browsers, and then HyperMesh, and you can choose there. So we're going to use a utility tool for this, because this is a fast way of creating some RBE2 elements, which are rigid bodies. Now, the difference between an RBE2 and an RBE3 is that a rigid body element of a type 2 transmits infinite stiffness. So it doesn't transmit load, it will transmit infinite stiffness. Your rigid body element 3, that's the one that transmits load. So making sure you're using the correct rigid body elements for the type of analysis that you're doing as well is a big thing. This is a fast way of creating it, is if you go into utility and you go to geometry and mesh, what we can do here now, and this is also a big thing, this is not just creating RBE2 elements or rigid body elements, this is how you create a fast way to create a washer around a hole, which is always advised when performing these analysis, is get a washer created at least 1 or 2 elements deep. So as you can see, we've got one element there. We've got sort of an unrealistic washer that was created from our meshing, but generally you'd want to have another nice circle around that line there, and even if you've got the room, even pull another one. It just helps really understand the stresses that are happening in that area. So we go to add washer. Now what you can do here, so it's telling us to select our nodes, or you can also, so select your node. So that once you click that, the panel will come up. So I recommend always nodes by path. Select one node, select another node, and as you can see, it selects all those nodes in a path, and then just hit on the way around, and now we've got all the nodes of that circle. Now that can be done on edges, faces, anyway, but always check that if you do it on a full face, that they've followed the direct path that you've wanted. So we can just zoom in just to make sure. Yep, proceed. And it's just creating the washer. Okay, so here we go. So we're going to tell it one washer layer at a scale of 1, so it's only going to create one element deep. This is here where we can create the rigid spider along the hole. So for a rigid spider, you'll generally want a local coordinate system, so you can select both of them, and then you can tell it a minimum number of nodes around the hole as well, but we've got enough there, so we'll leave that off, and we'll just go add. Okay, so we've got to change the washer mesh, add washer to the mesh. So there we go. So our element thickness was a bit funny, so you can always change the number of layers you want or the scale value, which means that, so now that's gone half the element size, sorry. And we can see that now we've also got a rigid body spider created in there. So this is a fast way of creating those bolt holes, bolt nodes to create the beam. And you've got a nice flush circle around the edge. So you can create that with more layers if you wish. One or two layers, generally 2 layers is pretty good. I'd stick with 2. After that could be overkill. But for instance, for a hole like this, it's very difficult to get a washer in there. So what we'll do is I'll show you what can happen. By path, select it all, just go around. Okay. So it's just finding all the elements. Now I'm going to make that a real tiny scale value. Create my rigid spider. Okay, so we can see there how it's come off much smaller because we've got the room for it, so you need to be aware of that. If it went any bigger, it may not have been able to do it as well. Okay, so that's gone over fast, some rigid meshing, some 2D meshing. Now I'm going to show you how to quickly do your 1D meshing for bolts or axles, beams, bars. So what we're going to do, and the good thing is this has already created our nodes for it as well. So on the panel here, you can hit 1D, go straight to a bar. So first off, select your orientation. So N1 will be this node here, N2 will be that node. And now you don't need a third because we're only connecting 2 nodes. Then you go to node A, node B, and you see that? Boom. C-beam, that's C-beam, but that's how fast it is to do that now. That's because of the element type I had here. You can always change it to a C. You can change that to a C-bar. So I'm going to show you now how to update this. So that's a C-beam, but I want that as a bar element. So I now select update. It comes up with elements. I choose my element. Go to my element type, C-bar, update. Then you can update anything. You've got your local axis, property, offsets. I'm going to just update the element type. It goes to a C-bar. So that's pretty fast to be able to do as well. So that should hopefully help with a lot of your modeling. So as you can see, like even me speaking about it still only just took a couple of minutes to do. So it can be really quite fast to be able to do that. So what you also then want to do is go to, if you want this to now be a full visual bar or bolt, go to HyperBeam, and you want to and then you can, well, so I'd probably recommend maybe looking up HyperBeam. Hang on, because I can't see the thing. Hang on, I'll just move this out of the way. Tools. Should be in tools here. Sorry. So if you can't ever find anything as well, just hit Control F, and then you can type in what you're looking for. Okay, there we go. Sorry. So that's another way of finding it. If you're not too sure where something is, Control F, and then just type it in. We're just going to go to a standard section, and we're going to have a solid circle. We're going to create one. So then, once you choose that, choose your HyperBeam, choose your solid circle. Opens up this new window, and all we need to do is go double click down here on the radius value. Let's just say it's a radius of 2. You can see it change, and go File, Exit, return out of that. Sorry, it's just been a bit slow at the moment, my computer. Okay, so then in here, I'll go more of the properties at a later date, but we just quickly create a property, and you call it a PL solid. PBML, sorry. And you got your material. So the material. And now you choose your beam section. That's the one we just created. And obviously and then you assign that. So, because I didn't create another component for that, which I should have, you would then assign that by going to your component property, and you assign that property. Just quickly do it. And then you can visualize it by hitting in your 1D section, 1D detailed representation, and it comes up as your bolt. So that's how you can do that. So that's covered your 2D and 1D meshing. And now, does anyone have any quick questions about that? But I'll try and be a bit faster with the next couple. Sorry if it's taking a bit longer. I do apologise for that. Any questions about that? Okay, so what we're going to do now is, this is going to be a very quick overview of your 3D meshing. So this is a solid, to make sure. 3D, oh, it's not, sorry. It's a 2D, that's all right though. Now how I'll just explain how I would mesh this is, with your 2D section now, you want to do tetra meshes with your volume mesh on something like this. You do your auto mesh tool, select all your surfaces, because this could take a while to mesh. Change this to your tries, and then you'd mesh it like that. But I will show that on this section here. So this is a much more simpler section. Again, always check whether it's so this one's a solid section. So what we can quickly do is function F12. We'll change this down to 2. Choose the tries, surfaces, mesh. Now that was nice and quick. So we can link opposite edges, recalc all, mesh, and now you're able to manipulate that even more. So what you can do then, once you've got your 2D mesh there, is you return out of that, go to turn your mesh on. So this is how you turn your mesh on. This is how you turn your geometry. Geometry on, off, mesh on. Go to your 3D, then go HyperMesh. Choose your components. Now you can choose either HyperMesh, Remesh, volume tetra. So we'll do a volume tetra. So what I've got here is, because we're using a solid, select our solid, element size, put to the same element size we started our skin mesh with, 2, and we've got match existing mesh. So now one proof here, so I'll mask these, and I'll return out of this because I'll just show, mask, there's no elements, return, so these are your masking tools. Go back to the HyperMesh, use all that, now mesh. So this will take a little bit longer because it's got a few more elements to create, but it's not too many. So now what you can do to have a look at that is I return out of there, I'll mask those elements and turn off my geometry. Now you can see you've got a nice internal volume mesh that have been connected to your outer element, to your outer skin elements. So that's how you would generate your volume mesh, by using those 2D shell elements very quickly. And also, after using the cleanup tools on them, it should already be a very well connected mesh with good quality elements. So I will unmask all those. So that's one way you can do a solid mesh. Now if you go function F2, we're going to delete all those elements. We delete all. There we go. Okay, so with a solid like this as well, sometimes you want to do what's called a solid map. So how to do that is you would go to geometry, solids edit, and now we see how this is green. That's showing that it's a solid. But if we go to so by clicking this, we go to mappable, it's solid red, which means that at this geometry at the moment will not build a mapped mesh, which is a solid volume of hex, not tetras, hex. So it'd be cube elements. One way you can quickly do that is by using these, such as say we'll trim with a surface, so we're going to trim we can trim the solid. Yep. And we're going to trim with a plane. We'll go the x-axis, and then you choose a base point. Go to trim. You see how this sectioned off. Now, why that's gone slightly see-through is that means that is now mappable, but in only one direction. So what you can do now is we'll map it a little bit more. So we'll select our solids again, because now we'll split that into 2 solids. You need to select both of them. We'll trim on, say, the y-axis. Select this base point. Okay, so now we're starting to get somewhere with this. So see how this is solid green now? That means that is mappable in all directions. So once your section is all mappable, so all see-through or all green, you would then return out of that. You would go to your 3D section, solid map, and you can either go one volume or multiple solids. So depending how you want to map it, you can either do one volume at a time and build it yourself, or if it's all green, it's very quick to do multiple solids. So we'll just do one volume. We've got our volume to mesh, which is our solid. We'll just do one. Got your element size, and you can choose where you want your elements, to current component or solids and surface component. We'll mesh. And now what it's done is giving a really nice hex mesh. So we can have a look internally by hitting our mask tool, shift, left click, middle button, and there you can see that is a really good cube mesh inside there. So that's a very fast way. Again, if you've got small solid elements, like if you want to be doing like 3D meshing of bolts, this is a really good way of doing it. If you've got really, some good solid sections, again, another really good way of doing it if you don't want to use tetras. So you've got a lot of choice here as to what you can do and why you would want to do it. And so lastly, now, I'm sorry I had to whip through that. I'm going to show the exporting capabilities of this. So like importing, you would go to File, export. Now you can either export the exact same things that you can import. So for instance, we'll go to solver deck just to start with. So for OptiStruct, a .inp is a CFD file. So if I wanted to export this, like I wouldn't export this as a CFD file because we haven't meshed in Tetras, but meshed in hexes. So something like that would be exported as an OptiStruct file. As the solver deck, that would be a .fem file. As the model, that's going to be a H3D, which is the FE only. You can export just your geometry again. So if you've changed the geometry, so this is also good for if you're building a model to use in the AccuConsole programs, and you need a parasolid. You can do all your geometry manipulation, create it, then export it as a parasolid file, IGES files, TIA composites link, and you've got the BOM, got your connectors. But generally, again, probably the main sections everyone here will be working will be either the solver deck or the geometry. So yeah, sorry I had to go through that quite quickly, and I do understand it's a lot to take in 1 hour. Please, does anyone, again, have any questions up until this point or need any clarifying about anything else? So everyone thinks it's not too bad, or have I not covered something enough, or have I covered something too much? Please let me know, because your feedback as well really helps me to help build these webinars, because these webinars are for you as well. So please feel free to give some feedback on them. I understand this one probably wasn't as exciting as the Inspire one, but this sets up pretty much the rest of all the webinars, well, especially for OptiStruct, Radios, and the CFD one. Multi-body dynamics will be slightly different again, but this is the main setup for pretty much the whole HyperWorks suite. So I definitely recommend as well, like usual, check out Altair University. There's plenty of help on there for this. There's free downloadable books for meshing. You'll be able to do some tutorials and training on this if I haven't been able to cover something enough in depth, or you missed something. Jump on there, have a look, or get your team leaders to shoot me an email, and I'm happy to help out where I can. So yeah, but look, I think we'll leave it there, guys. Hopefully everyone was able to stay with me for that hour. But look, thank you very much, and enjoy your week. And next Monday we'll have our first proper analysis session on OptiStruct, which is going to be the linear and non-linear solver for your FEA. So thank you very much, guys. Enjoy the rest of your week, and enjoy your weekend, and I'll see you next Monday. I'm just going to stop the recording now. Okay.